Hey guys, how's it going? This video I'm going to go through this Leetcode A75, Koko eating bananas. This is a medium type of question, and this question was asked by Google for 11 times for the past 6 months. Let's dive in. This is not, as you can see, this is not the most popular question, but I think it's kind of interesting. So the question says, Koko loves to eat bananas. There are n piles of bananas. The ith pile has this number of bananas. Okay, the guard I have gone and will come back in 8 hours. So this is actually the constraint. Koko can decide her banana per hour eating speed of K. So this is our goal to search for. This is K. Okay, each hour she chooses to some pile of banana and eats exactly K banana from that pie. Okay, so each hour she can choose one pie, and then she can eat exactly K bananas from that pie. If the pie has less than K bananas, she eats all of them instead, and will not eat any more banana during this hour. So basically, what it says is, she within each hour she's committed to only one pile, and so she cannot eat like two piles in 1 hour. Okay. Also, Koko likes to eat slowly. Okay, so eating slowly means we want to decrease the K as low as possible, but still want to finish all the bananas before the 8 hours, right? Because the 8 hours later, the guards will come back. Okay, so this is another constraint. Okay, and we need to return the minimum. So this is the keyword minimum, because she wants to eat slowly, such that she can still eat all the bananas within the 8 hours. So basically, you can see there are two constraints in here. The minimum K, and also within the 8 hour, because she has to eat fast enough to finish all of them within 8 hour, but she also want to enjoy it. That's why she doesn't want to eat so fast. So you can see this is the constraint. So this is an optimization problem with these defined constraints. Let's look at some example in here after this wording. So we have the piles. The first pile has 3 bananas, second pile has 6, third pile 7, fourth pile 11, and the guard will come back within 8 hours. Okay, let's look at some graph in here. So the first pile has 3 bananas, because you can see 3 bananas over here. Second pile is 6 bananas. Third pile is 7. The fourth pile is 11 bananas, and then the K that our function is going to return is equal to 4 in this case. Okay, so why 4? Okay, and this is exactly why we need to write a function. So, but let's dive in to this example a little more. So if we set K, we write in here K equals to 4. So what does it even mean, right? So it means we go back to here, the definition. Okay, so yeah, so it's exactly K banana per hour. We copy it over. So that's the speed. Okay, K bananas per hour. Okay, let's investigate a little bit more. So, and also she can only commit to one single pile for each hour. Okay, so for example, for this pile, it takes her, because she eats 4 bananas per hour, so she can finish it within 1 hour. So done in 1 hour. Okay, for this particular pile. Okay, and the second pile, because again, she eats 4 bananas per hour, and there are 3 bananas only in this pile, so she can finish it within 1 hour. And this one, there are 6 bananas, so it takes her 2 hours. Okay, so done in 2 hours. And for the next pile, you can see it takes her also 2 hours. Okay, because in 2 hours the maximum she can eat at this bit is gonna be 8 bananas. Okay, and for the last pile, how long it takes her? It takes her 3 hours, right? Because the maximum she can eat within 3 hours is gonna be 3 times 4, which is 12 bananas. In this case, there are only 11 bananas in this pile, right? So that's why it takes her 3 hours. So in total, how long it takes her, right? 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 3 is 8. So in total done in 8 hours. Okay, and let's go back to this question, right? So the guard will come back in each hour. In this case, age is exactly 8, right? So that means Koko can finish all the bananas within 8 hours before the guard comes back. And so that's one example. Also, we have a second example and the third example. And you can work through this example on the piece of paper if you like, but this is the main idea. Okay, let's look at some more constraint. The number of piles within 1 and 10 to the power 4, and also the age. Okay, this is important, right? So age, the minimum number for the age is gonna be the number of piles. Otherwise, this problem is not solvable. For example, if we have 4 piles, if the guard comes back in 3 hours, right, and then Koko cannot finish all of them in any ways, right? So in age has to be like at least 4, right? So that's why this is the constraint is very important. Also the number of bananas, at least 1, at most 10 to the power 9. And we are gonna solve this problem using binary search. Okay, why binary search? Because we are searching for the optimized K. Okay, so imagine, this is basically a search problem for K, right? So K, actually, let's say K can be the lowest number. Let's say if Koko eats only 1 banana per hour, right? And in the extreme case, so she can eat like 100,000 or infinite amount of banana, right? In that case, she can finish all the piles within 4 hours, right? So let me write down over here. So the lowest K is 1, and the biggest K is infinity, right? So this is the range that we can think of. Or the biggest K could be like, in this case could be 11. So could be not necessarily infinity, could be max of the pile of n, I. Okay, so look at the biggest pile, and the farthest she can finish is just like she can eat like 11 bananas per hour. If she can do that, she can finish all these piles within 4 hours. Now we can do a little bit like binary search, right? So we know that it's gonna be between 1 and 11. What about we pick the middle point, right? And then let's say we can pick the middle point is gonna be 6, right? And then we can ask ourselves, can she, if K, so let's say K's range possible is between 1 and 11. So we can pick the middle point of 6. So we can ask ourselves, can Koko finish all the banana within 6 hours? If she can, right, we can maybe decrease the upper bound. If she cannot, right, we can increase the upper bound. We can, so let me say again, maybe I say something stupid. Okay, if she can, right? If she can, that means the speed is okay within the 8 hours. If she can, maybe we can decrease the speed a little bit. So we can decrease the upper bound. If she cannot, we can increase the lower bound. So increase her speed, right? So it's gonna be increase the lower bound. So basically for each number we are checking, we are asking ourselves, at that speed, can Koko finish all the piles or not? Okay. And then we slowly narrow down our search to a case where it is a minimum K, right? And also finish all the banana within the 8 hours. Okay, at this point, I hope that is pretty clear on what we're gonna do. I'm gonna dive into the code now. Binary search. So I have a helper function here, hours text. I'm gonna walk through with you later. So this is the general template of the binary search, right? First, we have a left pointer and the right pointer, and this is gonna be initialized as 1, and maximum, the number of biggest pile, okay? And the mean K is something I'm gonna return at the end, okay? So in this case, let me put it away. Hold on, let me put it over here, okay? In this case, the maximum number of the piles is going to be 11, right? So the left pointer is equal to 1, right pointer equal to 11, okay? The mean K is something we're going to return at the end. Okay, so this is the speed that we want to optimize. And now we have the standard template for a binary search. While the left pointer is less than or equal to the right pointer, so we will do this while loop until they overlap. They cross it over, okay? And we detect the midpoint. So the left pointer plus the right pointer subdivided by 2. And now we have the solution for K, right? And then now we check if Koko is all the piles at the speed of M. So you eat all the piles at the speed of M. Can she finish it, right? So this one compute the number of hours she needs to finish all the piles at the speed of M. If the number of hours is greater than age, right? So it means she will finish it after the guard comes back. That means she's eating too slowly. And then we have to increase Koko's speed, right? So we can increase the lower bound. So we push the lower bound becomes M plus 1. Otherwise, she finishes it within the allowed time. And we found a potential solution, right? The minimum K, and then we can set it to be the middle point. At the same time, we can decrease the upper bound. Because at this point, because she may be potentially eating too fast, but she want to eat slowly, right? So we can decrease the upper bound to be M minus 1. So now let's look at this function, hours text, okay? It takes 2 arguments. One is the speed, another one is all the piles, okay? For all the P in piles, if we can do a complete division, the hours that we're gonna increase, hour needed, we're gonna increase, it's gonna be the pile, the amount of banana divided by the speed. Otherwise, we just have to increase by 1. So why we do that? Okay, let's look at the example over here. So in this case, right, for the first pile, we have 3 banana, and the speed is 4, right? So 3 divided by 4, we have remainder of, right? The remainder is not 0, right? We have some remainder. So gonna be So in that case, so we jump to the else statement. Okay, so it's gonna be 3 subdivided by 4 plus 1. Okay, and this is the number of hours we need to finish the first pile. The second pile is gonna be 6 divided by 4 because we have remainder, right? Plus 1. This is the number of hours, which is 2. Okay, same for this one. So 7 subdivided by 4 divided by 1, 2 hours. For this one is the same, right? 11 subdivided by 4 plus 1. So it's 3 hours. So this is exactly how we formulate that calculation on a Python code. So that's basically it. We just keep searching for the minimum k that satisfies the constraint. Okay, let's submit that, and it works. Okay, and for time complexity, it's going to be for binary search, it's going to be log n, as you might guess, and being the range size, right? In this case, r minus l times this operation, right? For this, when each of the comparison, we also have to compute how many hours it takes to finish that all the piles. So let me write down over here. It's gonna be big O of log of the range. Range is r minus l potentially plus 1 times times n. N means number of piles. Num piles. Okay, this time complexity, because the num piles comes from here. We need that much time to compute how many hours it takes to finish all the piles. For space complexity, got a BO1, right? We have just only like 2 pointers, also 1 min k to keep track of the observation. Yeah, that's basically it. And also I have a slightly cleaner way to do this. If you're interested, feel free to look at the code, but it's doing exactly the same thing, but it's a cleaner way to do the same thing. So yeah, there you go. This is my solution to this problem. I hope you find this helpful. If it is, please like and subscribe. Thanks so much for watching. See you next one.